Hello and once again welcome. Uh, in this session I'm going to continue with sequences and series for the IBDP course, and this is for the SL and it's from the AA, and the book that I'm referring to is a Oxford publication book. Now in this exercise 1A, okay, let us try to see this question number 2. Question number 2 says that for each of the following sequences, find an expression for the general term and state whether the sequence is arithmetic or geometric or neither. So let me tell you, for an arithmetic sequence, okay, that is AP, okay, the general formula is un is equal to a plus n minus 1 times t, where a is the first term and d is the common difference. And for a GP, the general term un is equal to a times r raised to n minus 1, where again a is the first term and r is something called common ratio. Okay, so let us start with A, sub question A. The sequence is 10, 50, 250, 1250. Okay, 10, 50, 250, 1250. Now if you see, 10 multiplied by 5 gives us 50, 50 multiplied by 5, okay, 50 multiplied by 5 gives us 250, and 250 multiplied by 5 gives us 1250. Okay, so you see that on multiplying by a constant number 5, we get the successive terms. But this 5 is known as common ratio. Okay, this is known as a common ratio, and because it is having a common ratio and the first term is also given as 10, we can conclude that this is a GP. Okay, so therefore this sequence is a GP. They told us to identify, right? Okay, state whether the sequence is arithmetic of GP. Okay, so this is a GP, number 1. Okay, now they have asked us to write the general term also. So as I told you, general term for any GP is un is equal to a times r raised to n minus 1. For this particular sequence, it will be a is 10 times r is what should be r, 50 upon 10 is 5. Okay, so 5 raised to n minus 1. So this should be the answer. Okay, so it's a GP, and sequence, the general term will be 10 into 5 raised to n minus 1. Right? Okay, this can be still simplified, but it's okay if you leave the answer that only. So that was A. Coming to B, the sequence B is 41, 35, 29, 23, and then it goes on. Okay, so you can see that 41 minus what will give you 35, so 6 minus 6. Okay, 35, 41 minus 6 is 35. 35 minus 6 should give you 29. Okay, and 29 minus 6 should give you 23, isn't it? So you can see that there is a difference, okay, a common constant difference of minus 6 as you go from left to right. So we say that this is having a common difference of minus 6. Okay, minus 6. See, how you get minus 6? You have to see the difference this way. 35 minus 41, it will be minus 6. 29 minus 35, it will be minus 6. Okay, so you should always go from right to the left. Okay, here also you should go from right to the left. 50 divided by 10 is 5. 250 divided by 50 is again 5. Okay, so either you do this way or you do this way. If you do this way, the difference will be minus 6. Okay, and forget this. I don't want to confuse you. You should always go this way only, right? So minus 6, minus 6 and minus 6 you are getting as the common difference, isn't it? Here also on dividing 50 by 10, okay, on dividing 50 by 10 you get a 5. Okay, 250 divided by 50 you get a 5, and this you get a 5. Okay, so here in this case the common ratio was 5. Okay, here the common difference is minus 6. Okay, here also I'm removing this so that you don't get confused. Okay, stick to one method. Okay, fine. Now the common difference is minus 6, so the general formula, so it's a AP. Okay, therefore whenever a sequence has a common difference, okay, this sequence is AP, right? And the general formula for AP is given as A plus n minus 1 times D. So A in this case is 41 plus n minus 1, D is minus 6. Okay, so this will work out to 41 minus 6n plus 6, which is nothing but 41 plus 6 is how much? 41 plus 6 is 50, 47. 41 plus 6 is 47 minus a 6n. Okay. So this is the general term. Okay, that was B. Okay, now coming to C. C is question number 2C. Okay, it's 1 over 3, 1 over 9, 1 over 27 and 1 over 81. There's a minus also. Okay, okay, now let us see whether it is an AP or GP. Okay, so let us do this. Minus 1 over 9 divided by 1 over 3. What we get, let us see. This will be minus 1 over 9 into 3, which is equal to minus 1 over 3. Okay, now let us do this. So 1 over 27 divided by minus 1 over 9. Let us see what we get. So this will be 1 over 27 multiplied by minus 9. Okay, this should give you again minus 1 by 3. So can you see minus 1 by 3? Okay, so can you see you are getting a common ratio of minus 1 over 3. This is a common ratio. Therefore you can say this sequence is a GP. Okay, and because it's a GP, you can say that the general term UN will be equal to A times R raised to n minus 1. In this case, A is 1 by 3, R is minus 1 by 3 raised to n minus 1. Now let us simplify this. This can be written as 1 by 3 multiplied by minus 1 raised to n minus 1 upon 3 raised to n minus 1, right? This is equal to minus 1 raised to n minus 1 upon 3 raised to 1 into 3 raised to n minus 1. This will work out to minus 1 raised to n minus 1 times this will be 1 upon, this will be 3 raised to n. So your final answer will be UN will be equal to minus 1 raised to n minus 1 upon a 3 raised to n. So this is the general term. Okay, and it's a GP. So first three we have decided whether it's an AP or a GP. Okay, and we found out the general term also. Now let us go for the D one. Okay, D is 1 1 2 3 5 8. What is D? D is 1, 1, 2, 3, 5, 8, and then it goes on. Okay. Now you are going to be introduced by the heading of this today's video, which is something called the name of this, one second, okay, is something called recursive sequence. Can you see here? Recursive sequence. Okay. Now we are coming to a new concept of recursive sequences. Okay, and this you have not studied earlier, I suppose, and you are studying for the first time, I suppose. Okay, so recursive sequence is something we are going to start with today, right? And that is today's heading also, recursive sequence. Now what are recursive sequence? Okay. Now if you see this sequence, it looks very weird, like you cannot say that it's an AP, you cannot say it's a GP. Okay, by no ways you can say that this is an AP or a GP. Okay, there's no pattern, which can be decided. There's no pattern also. Okay, there's no difference method also. I taught you one difference method: first difference, second difference, third difference. That difference method is also not giving you any hint. So this all are not working. Okay, so what kind of a sequence is this? Is this a new type of a sequence? And the answer is yes, it's a new type of a sequence. Now what is the name of that sequence? It is recursive sequence. Now what is a recursive sequence? Recursive sequence is a sequence where the successive terms, are not related, but the successive general terms are related. Okay. Now what I mean to say is, in this, suppose this is UN 1, 1, 2, 3, 5, 8. This is a sequence. These are known as the terms. Okay, so these terms are no way related. Okay, there's no relationship, there's no pattern between the terms. Okay, but if you find out U1, U2, U3, U4, etc., then you will find that there is some relationship between these. Okay, so that is what I mean to say is there is some relationship between the general terms. Okay, these are general terms. Okay, now let us see how it works. So first let me go to the concept of this particular thing. Now I have to do one thing. I have to minimize a little. Okay, fine. Now the whole screen can be visible, right? Okay, so now we are talking about recursive sequence. Okay, so consider, now I am here, consider the sequence -4, -3, -1, 3. We'll come back to this question number D. Okay, we'll come back to this. Okay, first let me explain you what is recursive sequence. So consider a sequence of this type: -4, -3, -1, 3. Now this sequence also -4, -3, -1, then again 3. Okay, now this type of sequence, there's no way that you will come to any conclusion that it's a AP or a GP. Okay, so what we notice in this is neither a AP nor a GP. Okay, so you can see clearly it is neither a AP nor a GP. So is it a new type of a sequence? Yes, it is a new type of a sequence which is known as, or which is called as, recursive sequence. Can you see this? Recursive. Now what are recursive sequences? Let us come to that. The definition says that the recursive sequence uses the previous term or the terms to find. So this recursive sequence will be making use of the previous terms, okay, along with the successive terms. Okay, so previous term or terms to find the next term. The general term, which includes the notation un minus 1, means the previous term. So the recursive sequence, if it's a recursive sequence, it will have some general term. Okay, suppose the general term is un. So in this general term, you will have notations like un minus 1 and un plus 1. Okay, un. These type of notations you will find in the general term. Okay, which so far you were not observing. Okay, so in the general term of an AP or GP, you never saw these terms, right? We never saw this. Okay, but now in recursive sequence, in the general term of the recursive sequence, you may see this or this. Okay, this type of things. Okay, so basically, what is recursive sequence? It is a relationship between the previous and the successive terms. Okay, so there will be some relationship between the previous and the successive terms, but the relationship will be in terms of the general term. Okay, now let us take an example. For example, suppose you are given a general term of a recursive sequence as this. Okay, so can you see this? This is the general term. Un is equal to 2 times un minus 1 plus 5. Okay, now this is a general term in which you can see this un minus 1. Okay? I told you in the general term of recursive sequences, you will be able to see such notations un minus 1, un. Okay, so un plus 1, such notations you will be able to see. So here you can see such a notation plus 5. And moreover, he says that u1 is equal to minus 4. So the first term is also given as minus 4. u1 is equal to minus 4. Now, using this information, can you find the second term and can you find the general term? General term is of course given. This is the general term. But can you find the second term and the third and the fourth and the fifth successive terms? All you can find out. Okay, so how you have to go ahead? So now in this, you have to understand the general term of this recursive sequence is un is equal to 2 times un minus 1 plus 5. Now in any sequence, in any sequence, okay, for example, if you take this minus 4, minus 3, and then minus 1, 3, in this sequence it goes on. Okay, this is known as the successive term and this is known as the previous term. Okay, I am writing P for previous, S for successive. Okay, so minus 4 is a previous term and minus 3 is a successive term, if you see these two in pair, right? So in general, this previous term is written as u1 and this is u2. So among u1 and u2, the previous term will be u1 and the successive term will be u2. Okay, among u2 and u3, the previous term will be u2 and the successive term will be u3. So minus 3 becomes previous and minus 1 becomes successive. If you see this minus 3 and minus 1 together, in minus 3 and minus 1, minus 3 is previous, minus 1 is successive. Okay, so previous means the term which is to the left, successive means the term which is to the right, and you have to see between any two successive terms or the you can say consecutive terms. Okay, now among minus 1 and minus 3, again your previous term is minus 1, the successive term is 3. Okay, so this you should remember. So in this case, un minus 1, okay, un minus 1 will be the previous term and un will be the successive term, isn't it? Un minus 1 will be previous and un will be, suppose this un is 5, so u5, and un minus 1 will be 5 minus 1 is 4, so u4. So can you see this u4 is a previous term and u5 is a successive term, isn't it? So previous term can be written as un minus 1 in general, and successive term can be written as un in general. So here you can see that this is a previous term and this is a successive term, isn't it? Un minus 1 is previous and un is successive. Okay. Now they have asked you to find out the second term u2. Okay. They have asked you to find out u2. So u2 is what? It is previous or successive? It is successive term. Okay. When compared to u1, u2 is successive term. So in place of un, you can take u2. In place of un minus 1, you can take u1. Okay, so 2 times u1 plus 5. Okay, and u1 is given to you. It is given as minus 4. So your u2 will be equal to 2 times minus 4 plus 5, which works out to u2 is equal to minus 8 plus 5, which is equal to minus 3. So you got the second term. In this question they asked you for the second term. Okay, so second term is what? It will be minus 3. Okay, so see the answer here is minus 3. Got it? Suppose they ask you to find out the third term for the same thing. Okay, the third term can be found out by repeating the process again. So third term you will take the successive term, that is un, the successive will be 2 times. Now instead of this un minus 1, you will have u2 plus 5. Now u2 you just now find out, it is minus 3. So minus 3 into 2 is minus 6 plus 5. So your third term will be minus 6 plus 5, that is minus 1. So second term was minus 3 and the third term is nothing but minus 1. Okay. Can you see the third term we got as minus 1, right? Okay. So I suppose now you are understanding the meaning of this recursive sequence. Okay. So you have to take care of successive and the previous. Okay. The un, the general term of a recursive sequence, is in terms of something called previous and successive terms, right? So coming back to this particular question D, 1 1 2 3 5 8. Okay, now you can see here that the general term is not given to us. Is it given? No, it is not given, right? So let us take this 1 1 2 3 5 8. This is term number 1, term number 2, term number 3, 4, 5, 6. These are the position numbers, okay? These are the term numbers, okay? Here you can say, right? Okay. So, what is the question here? Is it a AP or a GP? So, first of all, it is neither an AP nor GP, okay? As you can see, it's neither a AP or GP. This is the sequence, okay? These are the position numbers, 1 2 3 4. Okay, fine. Now let us try to find out if there is any relationship between the previous and the successive. So here you can see that if I take the first term u1 and the second term u2, and if I add them, u1 plus u2, 1 plus 1, I get nothing but the third term u3. And I see that first term is 1, second term is also 1, and when I add first and second term, I get the third term, which is 2. Okay, so u1 plus u2 is equal to 3. Let me check for u2 plus u3. Okay, now u2 is 1, u3 is 2, and when I add 1 and 2, I get the answer as 3, which is nothing but u4. So can I see u2 plus u3 is equal to u4? Okay, so this way I can see everywhere, right? Here also I'll see 3 and 5. 3 is what? It is the fourth term, u4. 5 is what? It is the fifth term. So 3 plus 5 is what? 8. And 8 is what? It is the sixth term. Okay, so you can see this happening. So you can write un, the general term, is equal to u n minus 1 plus u n minus 2. Okay, now what is n minus 1 and n minus 2? Un will be, suppose this is u6, n is 6. So this will be 6 minus 1, so u5, and this will be 6 minus 2, so u4. Can you see? u4 plus u5 gives me u6. Okay, u4 plus u5 gives me u6. So this is the general term for our recursive sequence, this sequence. Okay, 1 1 2 3 5 8. For this sequence, this is the general term. Once you get the general term, you can always find out the other terms also. Okay, but that is not the question. The question is what? See the question. The question is 1 1 2 3 5 8. This is a sequence given. So for each of the following sequences, find an expression for the general term. They have asked us to find out the expression for the general term, which we have found out, and we have to state whether it is a arithmetic sequence or a geometric sequence or neither. So there are two parts to this question. So both the parts we have answered. First part is what is the general term? So this is the general term, un equal to un minus 1 plus un minus 2. Okay, and what is the type of this particular sequence, whether it is AP, GP or neither? So the answer is neither. So it is neither an AP nor a GP. In fact, it is recursive sequence. Okay, so recursive sequence is something that has a general term of this form. Can you see? un minus 1, un minus 2 will be involved in the formula of the general term. This is the left hand side of the general term formula. Okay, fine. So you must have understood now what is the meaning of recursive sequence. Now quickly let us do a couple of more examples. Now you can see one example given over here and second example given over here. Okay, it's a solved example. So I'll just explain you, and we'll wind up this today's session. Okay, fine. So okay, so talking about recursive sequences, find the first 5 terms. You have to find the first 5 terms. Okay, find the first 5 terms for each of the following recursive sequences. Now these are recursive sequences. Okay, and the general formula un of this recursive sequences is given to you, right? So a1 is un equal to un minus 1 upon a 3 plus 3, and u1 is equal to 9. Okay, so the first term is given to you as 9, and the general formula of this recursive sequence is un minus 1 upon 3 plus 3. See, between un and un minus 1, which is the previous and which is the successive term? This is the previous term and this is the successive term, right? Un minus 1 always comes before un, right? So this is the previous term and this is the successive term, right? So you have to find out the first 5 terms. So first term u1 is already given to you, and it is how much? 9. u1 is 9. Okay, now you have to find out the second term, and then the third term, fourth term, and the 5th term. These are the first 5 terms. So if you want to find out u2, now u2 in comparison to u1 will be successive. Okay, so un is successive, corresponding to that un minus 1 is what? Previous term. So if u2 is successive, so previous term will be u1. So can I write u1 upon 3 and then plus 3. Okay, so this will work out to u1 is already given to you as 9. 9 upon 3 plus 3. 9 upon 3 is 3. 3 plus 3 is 6. So you get the second term as 6. The third term will be u2 upon 3 plus 3. which is nothing but u2. Just now you got 6. 6 upon 3 plus 3. This will be 2 plus 3 equal to 5. Okay. So third term is 5. u4 will be u3 upon 3 plus 3. u3 is how much? 5. So 5 upon 3 plus 3. This will work out 2 3s is a 9. 9 plus 14 upon 3. Right? And the fifth term will be u4 upon 3 plus 3, which is equal to 14 upon 3 times 3. Okay. Plus 3. 14 3s are 3 2s are 4 3s are 12. 2 1 carried 2 are 3 12 42 upon 3 plus 3. This is 42 plus 9 upon 3 is 42 plus 9 is how much? 9 10 11. I'm sorry. Okay, something wrong over here. This is 14 upon 3, that's correct. This is 5, this is correct. This is 6, this is correct. Here I made some mistake. Okay, it is u4 upon 3 plus 3. u4 will be 14 upon 3 into 1 by 3. Okay, I got it. So it should not be into 3, it should be into 1 by 3. Okay, so this happens to be 14 upon 9 plus 3, right? So 14 upon 9 plus 3, and 9 3s are 27. 27 plus 14 is 41, and this will be 41 upon 9. So these are the first 5 terms, okay, for this one. So can you see the first 5 terms? The first term is 9, then 6, then 5, 14 upon 3, 41 upon 9. Is that understood? This was an example of recursive sequence. One more let us do. Un is equal to 2 times un minus 1 minus 3. So now this un minus 1 is the previous term and this is the successive term. Okay. So if you want to find out u2 will be successive term and the previous term will be u1. So it is 2 times u1, so 2 into u1, and there is a minus 3 over here, minus 3. Okay, and u1 is given as 1, so u2 will be equal to 2 times 1, that is 2, minus 3, and 2 minus 3 is nothing but minus 1. Okay, u3 will be equal to 2 times u2 minus 3. Now u2 you just now got minus 1, so 2 into minus 1 will be minus 2, and minus 3 will be minus 5. Okay, so you are getting the answers as minus 1, minus 5. Okay, can you see? Minus 1, minus 5. Same way u4 will be 2 times u3 minus 3. u3 is minus 5, so minus 5 into 2 is minus 10, and a minus 3 will be minus 13. So can you see u4 is minus 13, and u5 will be 2 times u4 minus 3, which is equal to minus 13 into 2 is minus 26 minus 3, which is minus 29. So u5 you are getting as minus 29. So the first 5 terms are minus 1, sorry 1. The first term was given to you, okay, 1. So 1, second term minus 1, third term minus 5, fourth term minus 13, fifth term minus 29. Got it? So that's all about recursive sequence. It was a new concept and it got introduced into your IB, and I hope you must have understood the meaning of this recursive sequence. In the next session, okay, we will be doing some exercise questions on recursive sequence, and since this was a concept which I wanted to explain you, so that I have done. Now what I'll do is in the next session I'll do some numericals on this. Okay, so I'll be taking exercise 1B and doing some questions on that. Okay, so that's all for today. See you in the next session. Bye, take care all of you.